On April 10th, 2019, the entire world stopped. Not because of a war, not because of a disaster, because of a photograph. A blurry, orange, donut-shaped image appeared on the front page of every newspaper, every news site, every social media feed on the planet. Scientists were crying at press conferences. Journalists were struggling to explain it. Regular people were sharing it millions of times, and most of them had no idea what they were actually looking at. What they were looking at was this: the first photograph ever taken of a black hole. A real black hole in our universe, 55 million light-years away, weighing 6.5 billion times more than our sun. And today, we are going inside it. Before we jump in, let's understand what we were actually seeing in that image. Because most people think they saw the black hole itself. They didn't. What you see in that photograph is the shadow of a black hole. The dark circle in the center, that is where light has been swallowed completely. Nothing escapes, not a single photon. So your eyes and a camera see nothing, pure darkness. The glowing orange ring around it, that superheated gas and dust called the accretion disk, orbiting the black hole at nearly the speed of light. It's so hot it glows, and its light bends around the black hole's gravity so severely that you're seeing light from the back of the black hole, arcing around and reaching your eyes from the front. That orange ring is the last gasp of matter before it falls in forever. And we are about to follow it. The year is 2123. Humanity has cracked faster than light travel. And for reasons that history will debate for centuries, they chose to send one person directly into Sagittarius A. The black hole at the heart of our own Milky Way galaxy, 26,000 light-years from Earth. That person is you. Your rocket cuts its engines. You're coasting now, pulled forward by something you can't fight. Gravity on a scale that makes Earth's gravity feel like a suggestion. The first thing you notice is the stars. They're moving, arcing, bending, curving around a growing darkness directly ahead. This is gravitational lensing. The black hole's mass is so immense, it warps the very fabric of space-time, bending the path of light like a lens made of pure gravity. Stars that are actually behind the black hole are appearing in front of it, their light curving around the edges like water around a stone. Then you see it, the accretion disk. Just like in that photograph from 2019, except now you're looking at it from 100,000 kilometers away instead of 55 million light-years. It's not orange and still, it's violent and alive. A disk of gas rotating at fractions of the speed of light, so hot that it burns at millions of degrees Celsius, radiating X-rays and gamma rays in all directions. And at the center, a darkness. Not dark like a cave or dark like night, a darkness that feels like an absence. Like the universe forgot to put something there, like someone cut a hole in reality. Before you reach the point of no return, you pass through something called the ergosphere. This is a region just outside the event horizon that only exists around rotating black holes, and Sagittarius A spins fast, very fast. Inside the ergosphere, the black hole drags space-time itself along with its rotation, like a spinning top dragging the air around it. Except this isn't air, this is the fabric of reality. And it's being dragged so hard that nothing inside this region can stay still, not even if it wanted to. Even light, traveling at 300 million meters per second, is swept around in the direction of the black hole's spin. Your rocket thrusters fire constantly just to maintain any control. The instruments go haywire. Electric and magnetic fields in this region are strong enough to rip pairs of particles straight out of empty space, creating exotic radiation that pulses around your ship in waves you can see but not explain. This is the last place you could still theoretically escape, just barely, with everything you have. You don't escape. The void is absolute. Something strange is happening to time. Not your perception of time, actual time. The closer you get to the event horizon, the more intense the gravitational field becomes. And according to Einstein's theory of general relativity, gravity and time are linked. Strong gravity stretches time. It dilates it, slows it down. If someone back on Earth or even just far from this black hole, were watching you right now through an impossibly powerful telescope, they would see you moving slower and slower, frame by frame. Your hand reaching for the controls would take hours to move an inch from their perspective. Days, years. You would never quite seem to cross the event horizon. You would just slow and redden and stretch and fade, as the light you're emitting gets stretched thinner and thinner by the gravity you're leaving behind. From your perspective, nothing feels unusual. Your heartbeat is normal, you can read the instruments, you breathe. But everyone you have ever known has aged and died while you traveled the last 100 kilometers. And ahead of you, the event horizon. The line that once crossed means the universe outside ceases to matter, because you are no longer a part of it. No wall, no alarm, no flash of light, no sensation at all. The event horizon is not a physical surface. It is a mathematical boundary, a point in space-time. You cross it the way you'd cross an invisible line drawn on a sidewalk. You don't feel it, you don't see it. One moment you were outside, now you're inside, and the difference is everything. No signal you send now can ever reach the outside world, not a radio wave, not a laser, not a single photon of light. The escape velocity at this boundary equals the speed of light, and nothing in the universe travels faster. Every path forward from this point leads only one direction, toward the singularity. You cannot orbit, you cannot brake, you cannot turn around. Forward is the only direction that exists, and forward is down. You are now in the one place in the observable universe from which there is no return. Scientists have a word for what comes next. They call it spaghettification, and yes, that is the real scientific term. As you fall deeper, the difference in gravitational pull between your head and your feet becomes enormous. Your feet are closer to the singularity. They are pulled harder. Your head is further, pulled slightly less. The difference stretches your body, vertically, like taffy, like pasta being pulled from both ends. At first the sensation would be a stretch, then a pull, then the cells in your lower body begin to separate, not break, separate. The tidal forces here are so extreme, they overcome the molecular bonds holding matter together. You are being unraveled at the atomic level, drawn into a thin thread of particles, spiraling inward at speeds approaching the speed of light. You are becoming, in the most literal physical sense, a strand of matter a few atoms wide, a cosmic thread, a filament of what was once a human being, winding its way towards something the laws of physics cannot describe. The singularity. At the center of a black hole, at the very end of this journey, is the singularity, a point of infinite density, infinite gravity, a place so extreme that every equation we have ever written, every physical law we have ever discovered, every model we have ever built, divides by zero. They break, they stop working. General relativity, the theory that predicted black holes in the first place, cannot describe what happens inside the singularity. Quantum mechanics cannot either. The two greatest frameworks in all of physics both fail at the same point. We don't know what the singularity is. We don't know what happens to matter that reaches it. We don't know if space and time even exist there in any form we would recognize. We have mathematical descriptions that point toward infinity, and infinity in physics is almost always a sign that our model has hit its limit, that we've reached the edge of what human knowledge can currently grasp. The singularity is the universe's greatest kept secret, and you are the only one who has ever been close enough to find out, and the only one who can never come back to tell us. Back in the real world, that photograph from 2019 changed everything. The Event Horizon Telescope captured that image of M87 Kais, a black hole 6.5 billion times more massive than our Sun. 3 years later, in May 2022, they did it again, this time photographing Sagittarius A, the black hole at the center of our own galaxy, our home galaxy, the monster we orbit without knowing it. Both images confirmed what Einstein predicted over 100 years ago with nothing but mathematics. The shape, the shadow, the ring. It all matched his theory of general relativity with stunning precision. A man who died in 1955 described the appearance of something no human eye had ever seen. And he was right, down to the shape of the glow. Scientists are now studying how matter spirals into black holes, how those jets of energy shoot out across entire galaxies, and what role supermassive black holes played in building the universe we live in. Every galaxy we've looked at closely has one at its center, including ours. Black holes are not monsters. They don't chase, they don't hunt, they don't care about us at all. They are simply the places where the universe runs out of rules, where everything we think we know about space, about time, about the nature of reality itself, reaches its limit and falls silent. That photograph from 2019 wasn't just a scientific achievement. It was humanity's first honest look at the edge of the knowable universe. A confirmation that the strangest things we imagined, things so extreme they seemed impossible, are real. They are out there. They have always been out there, waiting in the dark, 26,000 light years from the planet where you're watching this right now. If this journey left you with a question you can't shake, drop it in the comments. The best black hole scientists alive today have the same ones. And if you made it to the end, you survived the event horizon. Most people don't make it past the first 2 minutes. Subscribe, because next time, we're going somewhere even stranger.